Hi everyone, my name is Teteje Kepsi Richard. Welcome to my YouTube channel. Please remember to subscribe to my YouTube channel and hit the notification bell so that if I share video, you'll be the first to receive it. Today, we are going to discuss linear algebra. Linear algebra. If you are a mathematics student in the university, one of the courses you take is linear algebra. However, if you are an SHS student, don't say that I mentioned university so it's not your level. No, because linear algebra is just one topic in it is in your SHS course, which is matrices. Matrices. So watch this video till the end. Before this video will end, I will introduce you to matrices. We will talk about the definition of a matrix. We'll look at forms of matrix. Then, we'll talk about the addition and subtraction of matrix. We'll also talk about multiplying a matrix by a scalar. And if there is time, we'll talk about the multiplication of two matrices. So come with me. Yeah, so when we talk of matrix, a matrix is a rectangular array of numbers. You know, a rectangle. So when numbers are arranged in a rectangular form, then such array of numbers are known as a matrix. So for instance, if we have this, see 2, 4, 5, 6. You see they are being arranged in a rectangular form. So such are called matrices. Look at this. A, B is in a rectangular form. So we call it a matrix. Look at this. If we have A, B, C, D, E, F, G, H. They are in a matrix form. So matrices are just rectangular array of numbers. Remember, the entries in a matrix are called elements. They are called elements. So these entries here, 2, 4, 5, 6, they are elements. A, B, these are all elements. So the entries of a matrix are called elements. Now the next thing we talk about is the order of a matrix. Order of a matrix. How do we call them? How do we call matrices? So if we have a matrix like this, the numbers to this direction is the column, and this is the row. So you count the numbers in the column, then against that of the row. So the order of a matrix is just the row by the column. The row by the column. So for instance, let's look at this matrix. How many entries are in the row is 2. How many entries are in the column? 2. So we can say that this matrix is 2 by 2 matrix. Is 2 by 2 matrix. Now let's look at this matrix. How many entries are in the row? Is 2. How many entries are in the column? 1. So we can say 2 by 1 matrix. Now let's look at this matrix. How many entries are in the row? 2. How many entries are in the column? 1, 2, 3, 4. So we can say it's 2 by 4 matrix. So the order of a matrix, remember, is the row by the column. Is the row by the column. The next thing we'll talk about is the types or the forms of matrix that we have. So come with me. So the first form of matrix we will talk about is row and column matrix. Row and column matrix. Remember we said the order of a matrix is the row by the column. Is the row by the column. So if I write this n by n, then n is the number of rows and n is the number of entries in the column. N is the number of entries in the row and n is the number of entries in the column. So if I have only one entry in the row, but another number of entries in the column, we call such a matrix a row matrix. A row matrix. So let's look at this matrix. Look at this matrix. A, B. So how many entries are in the row? 1. Then we have a number of entries in the column. So we call such a matrix a row at this one too. 1, 2, 4. Look at this. We have only one entry in the row and 3 entries in the column. Remember, this is a 1 by 3, a 1 by 3, a 1 by 3 matrix. So such a matrix is a row matrix. A row matrix. The opposite goes for a column matrix. So a column matrix is the matrix in the form n by 1. Thus, we have a specific number of entries in the row and only one entry in the column. For instance, look at this matrix A, B, C. This matrix is a 3 by 1 matrix. Therefore, it qualifies to be a column matrix. It qualifies to be a column matrix. Look at this, maybe 2, 6, which is a vector. So this is a 2 by 1 matrix. It's a column matrix. It's a column matrix. So I hope you understand the column and the row matrix. The row matrix, there is only one entry in the row and some number of entries in the column. And the column matrix, there is only one entry in the column in another number, more than one entries in the row. I hope you get that. I hope you get that. Now look at another form of matrix. Okay, so another form of matrix is square matrix. What is a square matrix? A square matrix is a matrix having the same number of entries in the row as in column. So let's look at a matrix like this. Look at this, A, B, C, D. So how many entries are in the row? 2. So this is a 2 by 2 matrix. This matrix is called a square matrix. Let's look at this one. A, B, C, D, E, F, G, H, I. So look at this. How many entries are in the row? 3. How many entries are in the column? 3. So we call this a 3 by 3 matrix. So it's a square matrix. We have the same number of entries in the row as in the column. Such is a square matrix. We'll look at another form of matrix. Okay, so the next form of matrix we talk about is zero matrix. Zero matrix. Zero matrix is a matrix in which all the entries are 0. All the entries are 0. For instance, let's look at the matrix 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So that's a zero matrix. All the entries are 0. All the entries are 0. Now, before we talk about the next form of matrix or the next type of matrix, I want to explain something to you. If we have a matrix like this, 1, 2, 3, 4. This is a 2 by 2 matrix. The numbers here, look at this, the 1 and the 4. The entries there are known as principal diagonal. Principal diagonal. That's there. You know, a diagonal line is any line drawn from one side of a plane sheet to the other side. So this is a diagonal line. So if we have a rectangle like this, the line drawn from here to here is a diagonal. So the entries in the diagonal, that's the entries in the diagonal are known as principal diagonal. Principal diagonal. So let's look at this. Look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 3 by 3 matrix. Look at these entries. The entries here are in the principal diagonal. The entries are in the principal diagonal. So that will help us know the next form of matrix. So come with me. Okay. So the next form of matrix is unit matrix. Unit matrix. Before I start, unit matrix is denoted with the letter I. With the letter I. So now, we can say that when we have matrix like this, 1, 0, 0, 1. Okay, this matrix is a unique matrix. And what is a unique matrix? A unique matrix is a matrix in which all the entries in the principal diagonal are 1. And any other entry that's below and above the principal diagonal is 0. So this is a unique matrix for a 2 by 2 matrix. A unique matrix for a 2 by 2 matrix. Now let's look at the unique matrix for 3 by 3. So 1, 0, 0, 0, 1, 0, 0, 0, 1. See, the entries in the principal diagonal are 1. And any other entry below or above it are 0. This is very, very important. So this is the unique matrix for 2 by 2 matrix and the unique matrix for 3 by 3. I hope you get that. The next thing we'll talk about is the addition and subtraction of matrices. That's the next thing we'll talk about. So the next thing, as I promised you, is the addition and subtraction of matrices. Now, if we have a matrix A and it is equal to the entries A, B, C, D. This is a 2 by 2 matrix. Another matrix B and it is equal to E, F, G, H. Okay? And we are asked to find A plus B. It's very simple. A plus B. So what's A? A will be A, B, C, D. The matrix A, B, C, D. Now, the B is E, F, G, H. So to add them, it simply means add the first entry here to the first entry here. This to this, this to that, and this to this. So this will be equal to A plus B, B plus F, C plus G, then D plus H. D plus H. So this becomes our A plus B. What of A minus B? A minus B. The same way, A minus B. Remember the matrix A is A, B, C, D minus E, F, G, H. So our A minus B simply will be A minus E, B minus F, C minus G, and D minus H. D minus H. So we'll take a question and we'll see how we can apply this. So I hope you get it. Just add the first entry to this first entry here. Then the second entry here to the second entry here. The next entry here to this, then this to that. That's simple. Very easy. I will solve a question on it for you to get a concept. Okay, so there is a question on the board. It says if matrix A is 2 minus 1, 4 minus 5, and matrix B is 3, 2, negative 1, 4. Find A plus B, B plus A minus B, and B minus A. So let's see how we can solve that. So the first one, the matrix A, remember, is equal to 2, negative 1, 4, negative 5. And the matrix B is 3, 2, negative 1, 4. So our A plus B will be equal to 2, negative 1, 4, negative 5, plus 3, 2, negative 1, 4. So that's it. So what do? We add 2 to 3, so 2 plus 3 minus 1 plus 2, 4 plus minus 1, then minus 5 plus 4. What do we get? 2 plus 3 is 5, minus 1 plus 2 is 1. 4 plus minus 1 is 3. 4 plus minus 1 is 3. Then minus 5 plus 4 is minus 1. This becomes our A plus B. So our A plus B will be equal to 5, 1, 3 minus 1. I hope you get that. Now let's do the rest. The second one. Let's do the second one. That's B plus A. B plus A. So let's see. What's our B? What's our B? Our B is 3, 2, minus 1, 4. What's our A? Our A is 2 minus 1, 4 minus 5. So let's add again. So 3 plus 2, 2 plus minus 1, 2 plus minus 1, minus 1 plus 4, then 4 plus minus 5. Let's see what we get. Look at this, 3 plus 2 is 5, 2 plus minus 1 is 1, minus 1 plus 4 is 3, then 4 plus minus 5 is minus 1. So these are B plus A. Now let's look at our A plus B. A plus B is 5, 1, 3 minus 1. Look at B plus A. B plus A is also 5, 1, 3 minus 1. So we say that in matrix, A plus B is always equal to B plus A. Thus, addition of matrix is commutative. The addition of matrix is commutative. Now let's find the third and the fourth one. The third and the fourth. The third and the fourth. So we are finding A minus B. So what's our A? Is 2 minus 1, 4, negative 5, minus this time around. Minus 3, 2, minus 1, 4. So we subtract 2 minus 3, this 2 minus this 3, then minus 1, minus 2, then we have 4 minus negative 1, then negative 5 minus 4. This negative 5 minus 4. So now let's perform our operation. 2 minus 3 is minus 1. Minus 1 minus 2 is, there's negative 1 minus 2 is negative 3. 4 minus negative 1 is 5. That will be 4 plus 1, which is 5. And negative 5 minus 4 is negative 9. So this will be our A minus our B. Now let's find the fourth one, which is B minus A. B minus A. So now, what's our A? Our B, sorry. Our B right now. B will be 3, 2, minus 1, 4. Minus 2 minus 1, 4, negative 5. So now let's perform that operation too. So we have 3 minus 2, 2 minus negative 1, this 2 minus negative 1, minus 1 minus 4, negative 1 minus 4, then 4 minus negative 5. What do we get? 3 minus 2 is 1. 2 minus negative 1, that will be 3. That will be 2 plus 1. Negative 1 minus 4. Negative 1 minus 4, that will be negative 5. Then 4 minus negative 5 is 9. That will be 4 plus 5. So these are B minus A. Now let's look at our A minus B. Our A minus B, we have minus 1, negative 1, negative 3, then 5, negative 9. Then B minus A, we have 1, 3, negative 5, 9. They are never equal. So in matrix, we say that our A minus B is not equal to B minus A. Or in other words, subtraction in matrix is not commutative. Subtraction in matrix is never commutative. I hope you get this. I'll solve one more question on the 3 by 3 one so that you'll be abreast with it. Play over the video, you'll get the concept. Okay, so there is a second question on addition and subtraction of matrices. It says if matrix A, it is a 3 by 3 matrix actually, is 3 minus 1, 4, 5, 2 minus 1, 3, 4, negative 5. Then you have 2, negative 1, 3, 4, 5, 2, negative 3, 2, 5 for B. And the question is find A plus B, B plus A minus B, and B minus A. Just the first approach we use for 2 by 2 is the same approach you are going to use here. So come with me. So we have A plus B. What's our A? Our matrix A is 3, negative 1, 4, 5, 2, negative 1, then 3, 4, negative 5. That's our matrix A. Then our matrix B is what? 2, negative 1, 3, 4, 5, 2, negative 3, 2, 5. Okay, let's just add them. Because we wrote A plus B here. So we go. This will be 3 plus 2. That's the first, I mean the first. Then negative 1 plus negative 1. This negative 1 plus this negative 1. Then 4 plus 3. 4 plus this 3. Then we do for the second. 5 plus 4. 5 plus 4. 2 plus 5. Then negative 1 plus 2. I hope you get that. Then 3 plus negative 3. 3 plus this negative 3. 4 plus 2. 4 plus this 2. Then negative 5 plus 5. Negative 5 plus 5. So what do we get? Let's perform the operations on them. 3 plus 2 is 5. Negative 1 plus negative 1 will be negative 2. 4 plus 3 is 7. 5 plus 4, 9. 2 plus 5, 7. Negative 1 plus 2 is 1. 3 plus negative 3 is 0. 4 plus 2 is 6. The negative 5 plus 5 is also 0. This becomes our A plus B. I hope you get that. It's very simple. Now let's find the second one, which is B plus A, and see what we get. So what's our B? Our B is 2, negative 1, 3, 4, 5, 2. Then negative 3, 2, 5. That's our B plus our A plus the A. What's the A? The A is 3, negative 1, 4, 5, 2, negative 1, then 3, 4, negative 5. So how do we add? Them? Let's come to this side. How do we add them? 2 plus 3. 2. This 2 plus 3. I hope you get that. Then negative 1 plus negative 1. This negative 1 plus negative. Then 3 plus 4. 4 plus 5. 4 plus this 5. Then 5 plus 2. 5 plus 2. 2 plus negative 1. Then we have negative 3. This negative 3 plus 3. Then we have this 2 plus 4. Then 5 plus negative 5. We'll perform the operations on them. 2 plus 3, 5. Negative 1 plus negative 1, that will be negative 2. 3 plus 4 is 7. 4 plus 5, 9. 5 plus 2, is 7. 2 plus negative 1, that will be 1. Negative 3 plus 3 is 0. 2 plus 4 is 6. Then 5 plus negative 5 is also 0. This is our B minus E. What do we get for B plus E? Sorry. What do we get for B plus A plus B? A plus B is 5 negative 2 7 9 7 1 0 6 0. It's the same as this. So this buttress our point that addition in matrices is commutative. It's commutative. So we'll solve for the rest. We'll work our way and solve for the A minus B and B minus E. So find the third one, A minus B. A minus B. So what's our A? Is 3 negative 1 4. 5 2 negative 1. Then 3 4 negative 5. Minus our B, which is 2 negative 1 3. 4 5 2. Negative 3 2 5. Remember this time around is subtraction. So we go, this will be 3 minus 2, then negative 1 minus this negative 1, then 4 minus 3. Then we have 5 minus 4, 2 minus 5, then negative 1 minus this 2. We have 3 minus negative 3, 4 minus 2, then negative 5 minus 5. So we solve that, we perform the operations on that. 3 minus 2 is 1, minus negative 1 minus negative 1. That will be negative 1 plus 1. So that will be 0. Then 4 minus 3 is 1. 5 minus 4 is also 1. 2 minus 5 is negative 3. Negative 1 minus 2 is negative 3. 3 minus negative 3 is 6. That will be 3 plus 3. 4 minus 2 is 2. Then negative 5 minus 5. That will be negative 10. So this becomes our A minus B. I hope you get that. Just go over it. It's not anything difficult. The first to first, second to second, third to third. That's all. Now let's solve the third one. The fourth one actually. Which is B minus A. B minus A. So, what's our B? Our B is 2 negative 1 3, 4 5 2, negative 3 2 5, minus our A, which is 3 negative 1 4, 5 2 negative 1, then 3 4 negative 5. So perform the operations on them. So let's go. This will be 2 minus 3, this 2 minus 3, negative 1 minus the negative 1, this negative 1 minus this negative 1. Then 3 minus 4. 3 minus 4. Then what we have next? Well, 4 minus 5. Then 5 minus 2. This 5 minus 2. Then 2 minus negative 1. And the last one, negative 3 minus 3. Then 2 minus 4. This 2 minus 4. Then 5 minus negative 5. Now we perform the operation on them to get the answer. So 2 minus 3 is negative 1. Negative 1 minus negative 1. That will be negative 1 plus 1, which is 0. 3 minus 4 is negative 1. 4 minus 5 is negative 1. 5 minus 2 is 3. 2 minus negative 1, that will be 2 plus 1, which is 3. Then negative 3 minus 3, that will be negative 6. 2 minus 4, that will be negative 2. Then 5 minus negative 5, that will be 10. That will be 10. So look at A minus B, 1, 0, 1. 1, negative 3, negative 3. C is 2, negative 3. Let's look at the B minus B. That was negative 1, 0, negative 1. Negative 1, 3, 3. Negative 6, negative 2, 10. They are not the same. So A minus B is never equal to B minus B. So subtraction is not commutative when it comes to matrices. Please, we'll end it here. In our next video, we'll try to find, to multiply a matrix by a scalar. We'll also do the multiplication of two matrices. Then we'll take it from there. Please remember to subscribe to my YouTube channel and hit the notification bell so that if I share video, you'll be the first to receive it. Bye-bye.